is going to be always larger. That fraction is going to be always, that will be always a fraction. Times 100 will give you the percent yield. So it's not a big deal. Okay, we'll go through that on Wednesday. But you already probably understood it, right? How many people didn't understand the concept of yield? Raise your hands. Well, maybe you will understand now we're doing the problem, okay? So, what is the actual yield according to the definition in this problem? Do we know the actual yield, experimental? Do we know it? How much is it? How much? Actual yield is equal to what? How much? Loud. Loud. Yes. 500 grams of C. That's what the actual yield is. The problem says so. Yes? Yes. Now, we have the molar mass of A and the molar mass of C. The problem is giving it to us. It's good to write these things down when you take the exam. And we want to calculate the theoretical yield, which is going to be, we want to calculate the percent yield, which is going to be actual divided by theoretical. So really, the only thing we need to calculate now is what? Theoretical. Because then we can know the percent yield too. So the only thing we need to find out is the theoretical yield. And the theoretical yield is calculated by using the chemical equation. Yes? So, here's the chemical equation. A general one, by the way. Makes things easy. And according to the mole ratio of the chemical equation, we're going to calculate what is the theoretical yield. Where do we start and where do we go? We start with how many grams of A? 100 grams of A. You agree with that? 100 grams of A. And we want to find out how many grams of C we get. Yes? Why we will not go into moles? We have to go into grams. Because we already have the actual yield in grams. So when you divide actual yield to theoretical yield, both, they have to be in the same units. They can be in grams, they can be in, they have to be in the same units, right? So that's why. All right, so we have so many grams of A, and we want to find out how many grams of C you will get. We did that problem just a few days ago. You remember how we did it? We went from grams to grams, a train with 3 mole ratios. How many people remember? Let me see your hands. Okay, most of you will remember that. It's exactly the same problem. So, from grams, I'm going to go to moles of A by using the molar mass that the problem is giving you. And that's 1 mole of A divided by 20 grams of A. And then through the equation, we're going to find out how many moles of C you get from so many moles of A. Yes? So the ratio is 3 moles of C per 2 moles of A. And then from moles of C we want grams, so we're going to use the molar mass of C, which the problem is giving us, 72 grams of C per mole of C. Mole C goes away, and we find out that it's 540 grams of C. Okay? And therefore, the theoretical yield is 540 grams of C. Okay, now we can calculate the reason that I want the percent yield, right? So percent yield is going to be equal to fraction, right? Smaller number on the top because always has to be a fraction. So it's going to be, which is smaller always, we said? The actual yield. So it's going to be actual divided by theoretical times 100. So if you do that, it will be 500 grams of C divided by 540 grams of C times 100, and that will give you 92.6%. How are you doing? Are you doing good? You enjoy yourselves? How many people enjoy themselves? How many people don't enjoy themselves? Why not? Why not? Why you are not enjoying yourself? Oh, okay. It's good. It's very good sometimes to joke. We need to learn to focus. And when you came to this review session, many of you were talking. You were not focusing on what you were ready to do and what is pertinent and important to this 1.5 hour or 2 hours, whatever, of our religious session. You should have come and you should be in silence to focus. If you focus, the more you will get birds in your hand without even looking at the birds. You don't believe it? See the movie Way of the Peaceful Warrior and read the book. It will be the best thing that you can do during college, for your college life. During your college life, the best thing that you can do is to see the movie and read the book, The Way of the Peaceful Warrior. Are you going to do it? How many people are not going to do it? How many people are going to do it? Let me see your hand. You give a promise to yourself you will do it? You think your teacher will tell you something that will benefit you greatly? Do you doubt that? You have to trust your teachers. Okay. Let's do this problem here, which is interesting. You might have seen this type of problem before. And it's interesting because you can solve it different ways. And you see, when we learn to think and not act like machines, someone can walk out of the classroom and does the exam in 30 minutes, 20 minutes. And other people struggle for 40 minutes, 50 minutes, and still they cannot finish half of the exam. And you say, why is this happening to me? It's happening because you have not been taught, it's not your fault, to think logically. You just have been taught to act like a machine when you are a human being, and you have been taught to act like a human doing. That's why. So here's a problem that illustrates this. If you want to solve this problem and you start calculating for every answer, A, B, C, D, E, right? To see if it's true, forget it. It will take you probably 15 minutes, and you will make a mistake, and then you miss the exam. Just one problem can completely destroy your exam. There is a middle ground. There is a middle ground that you can do just 1 time 1, observe something, and then you make up your conclusion just like that. And then there is a highest degree of thinking that you just see the big picture like this. And you say, abracadabra, bam, that's it. And you don't do any calculations. Which way do you want me to do it? Bam? Look, there are all 5 grams. Yes? There are all 5 grams. No pen, no paper. Like I said, somebody could just calculate every one of them and make 1.5 page calculations. Surely would make a mistake, forget it. Or you can do one calculation, find the result, how it looks like, and then he makes a conclusion. Ah, now I know. Okay. So let's say that you have 5 grams of metallic tubes. Yes? 5 grams of metallic tubes, identical. One case either this size, and the other case is double size. If you put them together, stack them together, right? They're all 5 grams in each case. Yes? Where would you have more tubes? The ones that are this size or the ones that they are double size? Where you will have in these stacks, 2 stacks, more tubes? You know, where? The one that has the higher mass or the lower mass? That's it. So what's the answer? See? Isn't that cute? So no calculation. You want me to talk about the second one? How to do the second, the middle ground? In the middle ground is you can start with one. Let's say you take 5 grams of chlorine. Let's say it doesn't matter. You can take any one of them, right? Let's say 5 grams of chlorine and see. Let me see how many numbers of atoms of chlorine there are there, right? So if you do that, you will start saying, okay, I have 5 grams of chlorine, make it into moles of chlorine, CO2, make it of moles of chlorine atoms, you make it atoms of chlorine, Avogadro's number, eventually you see that The number of chlorine atoms for 5 grams of CO2 is this one here. Look at it. It's 5 Na divided by 35.5. Then I'm afraid that you have to do it another time. You have to do it for another one. Otherwise, you might not get it. Well, maybe you can. No, you can get it. So you're looking at this, you just about CO2, right? And what do you see? It's 5 Na divided by 35.5. You know Na is a constant. You know that that 5 has nothing to do with chlorine. It came up in there from the 5 grams, which is in each case the same. Right? So Na is a constant, 5 is for every one, every sample. The only difference is this. Oh, I see, that's the only difference. So if I want the greatest, then I want this number to be the lowest. There you go, hydrogen, right? So you see, that's the middle ground. And the other one will be to do all of them and say, let me see which one is the greatest number, that one. Can you see how you can solve problems? Many different ways. And there's one fast like this, look. And then there's another one like a turtle. Right? So we need to start thinking, not memorizing. All right, now let's do a problem from the part number 3. Let's do this one. How many people have a costume, a local costume, traditional costume? Anybody? Today? Beautiful. There's one there. Azim is there. 2. How many? Anybody else? You guys don't have any roots? No roots? You have one? Yeah. Sick to find out the roots. Huh? Find your roots, cultural roots. Don't laugh. You do not know your roots, you're in the air. One day you will fall, and you will really bruise yourself really bad. Find your roots. Find the beauty of your roots. Traditional music, traditional dress, traditional food. Find your roots, and start loving them, and learn from them, just like your teacher did. If you want to see success, do that. And don't be embarrassed of your dress or your culture or anything. Because Martin Luther King's message was, we are all on the same boat. And if we don't realize it, the boat will sink. And it's going to be a big, big drainage. We need to realize that, and we need to accept each other, and we need to love the beautiful things of every culture. Instead of judging other cultures and thinking that ours is the best. Every culture has a lot of beautiful things. We need to focus on the beautiful things and forget the bad things. Otherwise, we have no future as a human species. We don't. Unless we change our attitude, we're not going to be around for too long. It's another joke. It's very serious. Okay, so you guys, you know how to do this? How many people think they know how to do this? Let me see your hands. So most people do not. Well, we're not really talking about that much, okay? So let's see. Well, it talk about solutions, right? Molarity and so on and so forth. Calculate the molarity of each type of ion remaining in solution after 50 milliliters of hydrogen iodide, 1 mole per liter, is mixed with 30 milliliters of 2 moles per liter potassium hydroxide, and you add after that, when you mix these two solutions, on the top you add what? 100 milliliters of water. You dilute it. The reaction mix will dilute it. You put more water. Okay. Assume that these reactants, potassium hydroxide, hydrogen iodide, they dissociate completely, right? Into ions. Don't have molecules or formula units, right? Ions. There is something which is very useful, and we'll talk about on Wednesday, and that is when you multiply the volume of a solution in milliliters times its molarity, in this case is 1 mole per liter. When you multiply, look, you multiply milliliters, right, times molarity, which molarity is moles per liter, right? Molarity is moles per liter, times milliliter. Liter and liter goes away, and what stays is millimoles. So that's something very important to know. You will use it in titrations later. Now, when you multiply the volume of a solution in milliliters times the molarity of the concentration of chemical species in solution, what you get is the number of millimoles of the species. So we're going to have 50 what? Millimoles of hydrogen iodide. The same thing you can do for the other reactant. 30 milliliters times 2 moles per liter molarity. That will give you the number of millimoles of potassium hydroxide. Okay? So now we react these two things. We put them together. This is an acid that produces hydronium ions, right? This is producing OH minus. And you know we already talked about it, right? You can consider it as H plus OH minus will give you water. 1 to 1 to 1. Yes? So really the reaction that's taking place is what? The acid, which is what? Hydrogen iodide plus potassium hydroxide gives you the salt and water. That's a very simple equation. We don't even have to balance it. And it's very good always to put what? To put the amounts, the quantities below the chemical formulas. That's the best way of solving chemistry problems when they deal with chemical equations. Remember that always, to do that, right? So, here's the equation I'm going to put below the chemical species, everything I know or I do not know. So here we are. Before, you write the word before the reaction takes place, before we mix them, what do we have? We have 50 millimoles of hydrogen iodide. And what we have? 60 millimoles of potassium hydroxide. You don't put the potassium hydroxide on the top of it. That's the point that we're doing that anyway. And we're talking about to find molarity of ions. So when the reaction is taking place and potassium iodide is created, that's in the form of ions, isn't it? It's a salt, right? So when you see potassium iodide, it is a salt, and when you put it in water, it dissociates. It's already like this, solid. When you put in water, liquid, it dissociates and becomes ions, aqueous, plus iodide, aqueous, right? So even though we see it like this, we actually, it's in the form of ions, like this. Yes? Okay, and how many millimoles do you have of that before we mix the solutions? How many millimoles of potassium iodide do you have? Loud? Come on, a courageous one, a warrior one. A warrior, a weapon warrior. 0 millimoles. A warrior who doesn't care about other people think and say about himself or herself. It's pretty hard to achieve that state. Try to achieve that state. Otherwise, you will never be happy. That you know what you know, you listen what other people think, but you are not moved by it. You don't make your decisions based on the opinions of others. Because then, you are not a human being. You are acting like a puppet. You don't want to be a puppet. You are like. Why would you act like a puppet? You don't want to act like a puppet when you are light. Thunders, lions, like Martin Luther King. You are. But you don't know it yet. When are you going to find out? When? In another lifetime? Don't wait. Now, here, change. By the way, we talk about change now. So, right, change, right? Okay. the equation tells us that one reacts with one. What one with one? 1 mole with 1 mole, or 1 millimole with 1 millimole, correct? Because the ratio of moles will be also the ratio of millimoles, right? So, what we see here that 1 reacts with 1, so 50 will require how many? 50 millimoles minus 50, that means they react, right? They will require how many potassium hydroxide reacting with them? How many? Huh? 50 millimoles, right? Millimoles. 50 millimoles. And how many millimoles of potassium iodide will be produced? 1 gives you 1. 1 reacts with 1 gives you 1. 50 will react with 50. React minus minus. And will produce plus, because they are produced. How many? 50. So after the reaction is done, after the reaction is done, how many millimoles do you have hydrogen iodide? 0. How many have potassium hydroxide? 10. How many potassium iodide? 50. Because it's the sum, right? Can you see that? The algebraic sum. Okay, so when this reaction is done, what is as the product, right, is what? We have 10 millimoles of potassium hydroxide that has not reacted, correct? Excess called. It didn't react. It didn't have enough of acid, so it's there. Excess is called. How many? 10 millimoles. And when we have 10 millimoles of this, that means we have what? Ions, right? Potassium plus OH minus, because that's soluble. It's strong base soluble. So we have how many millimoles of potassium plus? 10 millimoles of potassium plus. And what else? 10 millimoles of OH minus. Did you understand that? Okay? It's the same thing we have talked before. And what else do we have except besides the potassium hydroxide? We have also, after we have what? 50 millimoles of potassium iodide, the product. Yes? Which means we have what? 50 millimoles of potassium plus and 50 millimoles of iodine minus. And so now, that's what we have, all these 4. So this and that will make you what? That will make you 60 millimoles of potassium plus total. Yes? So you have that, and what else? The other 2, right? So we have potassium, this and that. So we have these 3 numbers, this, that, and that. Okay, we want to find molarity. We want to find how many moles of these ions are per liter of solution, yes? We know millimoles, but we want to find what? Molarity, moles per liter. So, well, we start with what we have. What do we have? We have, let's say for potassium plus. When we put potassium plus in brackets, it's a kind of a symbolism like that, it means molarity, moles per liter. Okay, so molarity of potassium plus is going to be equal to, if we want moles per liter, I have to have something that sounds like mole. So what do I have? Well, I have 60 what? Millimoles of potassium plus. And I want to know how many moles per liter. Well, what do I have as volume of the solution? The final volume of the solution will be how much? You put what? You put together 50, didn't you? Plus 30, the other solution. And then don't forget, you added what? Water. So the total volume is not going to be 80. Don't forget the 100 you added after you mix the solution. So the total volume will be actually 180 milliliters. And you don't have to do really much because look, millimoles and milliliters, milli and milli goes away, milli and milli goes away. And what happens is moles per liter. So if you do the calculations, you will find out 0.333 moles per liter, right? Moles of potassium glass per liter of solution, which is 0.333 m for potassium glass, right? Oops. The other ones are very similar, right? Aren't they? You can do it similarly. Look at them. They are too worried about their exam. Nobody can move his hand. No one. Do you want the teacher to tell you a secret? Don't tell it to anybody. Don't tell it to anybody. If you try to achieve a state of joy playing music, participating in music, not just listening to music. Dead people are listening to music too, you know, but they don't move because they're dead. So when we listen to music, we are not moving, crying, laughing, dancing, singing, making moving our head, that means we're dead. We think we are alive, but we're dead. So when we cultivate the ability to listen to music and sing, and we're in that euphoric state, we can do all the homework in a fraction of time, like this. Instead of doing it in 2 hours, you can do it in 15 minutes. And when you see that happening, you will go around and say, I have a secret, but I don't think you will understand it. So I better just shut my mouth and let you find about that. That's what you will think. Unless you have great love for others, then you will tell them the secret. Try it. It's called chanting. Find music that elevates your spirit instead of bringing it down, screaming and all this. Music that elevates your mind, your spirit, makes you go to eternity. Find that kind of music. And try to merge into it. And your mind is going to be like a thunder, like this. Just like that. Do the homework in a few minutes. Some students know this. They have glimpses of it. And they know your teacher, what he's talking about very well. They have experienced that sometimes. But the project is to be able to experience it continuously, all the time. Never in a hurry, never late, always on time, always no running, always in peace, always total control of your thoughts. Unmoved by what's happening around you. What people say, what they do, you are totally unmoved, just like Himalaya mountains. Every one of you can achieve that state. It depends how much really you want to do it. Because if you want to do it, you will achieve it in this lifetime. So let's do some problems from part 1 now. Right? Part 1. Let's do this problem. The so-called line structure, when you go and take organic, you will see quite a few problems like that. Much more complicated, of course. This is a very simple one. That's bad. Okay. So, this problem is asking you, what's the molecular formula of this hydrocarbon? So you just need to know the conventions, you know, what this kind of symbols mean. So, when we have lines like that, each corner where 2 lines meet, each corner and each end of line is a carbon atom. And therefore, another thing we know is that each carbon has to have how many lines around it? How many? 4. So it can be like this, look. It can be like this. It can be carbon like this. It can be carbon like that. It can be carbon like that. Any of this will do it. There are 4 lines around it, yes? And In this, it says it's hydrocarbon. So each corner and each end of the line is a carbon. So if it doesn't have 4 lines and there are some missing, the missing will be what? The number of missing lines will be what kind of atoms? Hydrogen, okay? So we have a square here, we have a square, and we have a line there, and we want to find out, it's a hydrocarbon, that means carbon and hydrogen. And we need to find X and Y. What is this and what is that? That's the only thing we need to do.